Good afternoon, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this particular video lecture series, I'm going to explain about the pulse position modulation. Pulse position modulation is a modulation technique in which the position of pulse varies according to the instantaneous value of the amplitude of the sampled modulating signal. The width of the pulse remains constant, only their position changes. Hence, the power of the transmission remains the same. The activity here is what is the role of channel in the communication system, whether it acts as a medium to send a message signal from the transmitter to the receiver, or it converts one form of signal to other, or it allows the mixing of signal, or it helps to extract the original signal from the incoming signal. The generation of a pulse position modulation is the signal here is produced, which is processed at the comparator to generate a pulse width modulation signal. After processing, the output of the comparator is being fed to an input to the monostable vibrator. Being negative edge triggered, the output of the vibrator goes high with trailing edge of the pulse width modulation. The trailing edge of the pulse width modulation shifts with modulating signal, creating the pulse position modulation pulses. Here comparator, then from the comparator the monostable vibrator is being given, then from will get a pulse position modulation signal. Then the detection of the pulse position modulation is the signal here produced is processed at the comparator to generate the PWM signal. After processing, the output of the comparator is being fed to the input of the monostable multivibrator. Being the negative edge triggered, the output of the vibrator goes high with the trailing edge of the PWM signal. The trailing edge of the PWM shifts with the modulating signal, creates the pulse position modulation signal. The waveform here is shown for the pulse width modulation signal. In this pulse position modulation, the analog signal modulated where the amplitude and the width of the pulse are kept constant, while the position of the pulse with respect to the position of the reference pulse is varied according to the instantaneous value of the message signal. The pulse position modulation can be obtained from the pulse width modulation. This is done by getting rid of the leading edge and borders of the pulse width modulation pulses. The first signal is analog signal. From that we'll get a carrier signal. The carrier signal here is a sampled pulses. It starts at the negative edge, that is trailing edge of the signal. And finally, the pulse position modulation. Here the position of the pulses varies in accordance with the amplitude of the signal. The various advantages of a pulse position modulation are: due to the constant width of the pulse, the transmission power remains constant and displays no variations. Then it shows better noise immunity as compared to an amplitude modulated signal. This is because the information in ppm is stored in position rather than the amplitude. Then the recovery process of ppm signal from its distorted form is easy and simple. Then it has a low system requirements. The drawbacks of a pulse position modulation are it requires large bandwidth as compared to other methods, which increases the bandwidth for the consumption. In order to perform the detection of this signal at the receiver, it is necessary that the transmitter and the receiver are synchronized. Then it is really sensitive to phenomena like interference, which can disturb a transmission by changing the difference in arrival times of every signal. The various applications of a pulse position modulation are: this modulation technique finds its application in air traffic control systems, in radio control, and in military applications. Since pulse position modulation is used in non-coherent detection when we don't require a receiver having a phase lock loop for tracking the carrier phase. Since this modulation technique helps in the compression of data, where it is often used for the storage purpose, then we can employ this pulse position modulation in the optimal communication. This is done to minimize the dispersion effect and will be using this efficiently for the laser power. Then in remote control systems in which a stream of pulses is used to encode the information in the bits. Assessment. What is mean by pulse position modulation, and also explain the various applications of pulse position modulation. Thank you.